Imagine an aircraft so powerful it could take off from the hot, thin air of a high-altitude city and fly clear across a continent. Now, imagine its manufacturer decided to kill it, convinced newer, more efficient planes were the future. But what if that future never came? Why is there a gaping hole in the aviation market that only this one obsolete jet can fill? And what does its strange survival tell us about the blind spot at the heart of modern innovation? Here's what's really happening. To understand this paradox, we have to go back to the late 1970s. Airlines were desperate for a replacement for the noisy, gas-guzzling Boeing 727. They needed something efficient, quiet, and capable of operating from the same airports. Boeing's answer was the 757, a single-aisle, twin-engine jet designed for the domestic American market. On paper, it was a practical, unglamorous workhorse, but Boeing's engineers did something they were famous for in that era. They overbuilt it. They gave it a set of wings with a sophisticated high-lift design, allowing it to perform exceptionally well at both low and high speeds. Then, they strapped on the most powerful engines ever seen on a narrow-body aircraft. Airlines could choose between the Pratt & Whitney PW 2000 series or, more famously, the Rolls-Royce RB211. These were not just engines, they were behemoths. They were scaled-down versions of the power plants used on massive wide-body jets like the Boeing 747 and the Lockheed L-1011. The result was a narrow-body jet with the soul of a wide body. It had a thrust-to-weight ratio that was frankly absurd. It could carry a full load of 200 passengers, climb directly to 41,000 feet, and cruise comfortably at Mach 0.80, faster than most of its modern counterparts. When it entered service in 1983 with Eastern Airlines, carriers quickly realized they hadn't just bought a 727 replacement, they had acquired a strategic weapon. But even they didn't yet understand the full extent of its capabilities. This plane wasn't just an evolution, it was an anomaly. An accident of brilliant engineering that defied the neat categories of aviation. But this raw power wasn't just for show. It translated into something far more valuable to airlines than speed or a thrilling takeoff. Here's the first clue to its longevity: that power gave it unprecedented flexibility. Airlines soon discovered the 757 was a Swiss Army knife. It could do everything. It could fly a short 2-hour shuttle between New York and Atlanta in the morning. Then, in the afternoon, it could take off from that same runway and fly 7 hours non-stop across the Atlantic to Shannon Island. No other narrow-body could do that. It single-handedly created the market for long, thin transatlantic routes, connecting smaller US cities to secondary European destinations without the financial risk of using a half-empty wide-body jet. Its performance was legendary. Think of airports like Bogota, Colombia, sitting at 8,360 feet, or Denver, the mile-high city. These are hot and high airports where thin air robs engines of their power and wings of their lift. For most aircraft, this means performance penalties. They have to operate with fewer passengers, less cargo, or reduced fuel. The 757 barely noticed. Its overpowered engines and advanced wings allowed it to take off with a full load, even on short runways, and fly thousands of miles. It opened up routes that were previously uneconomical or simply impossible. Then there was its short-field capability. Airports like John Wayne Airport in Orange County, California, have notoriously short runways and strict noise abatement procedures that require steep, rapid climbs. The 757 was the master of this environment. It could land on a dime and take off like a rocket, meeting the world's toughest operational constraints. It was the plane you sent to do the jobs no other plane could. It gave airlines a cheat code, one aircraft that could serve almost any role in their network, from high-density domestic routes to prestigious intercontinental flights. This wasn't just a plane, it was the ultimate problem solver. So if this aircraft was so uniquely brilliant, a true unicorn of the skies that minted money for airlines, why on earth did Boeing kill it? The answer is a story of market blindness and a strategic miscalculation that would haunt the company for decades. By the early 2000s, the aviation landscape was shifting. The era of overbuilt, overpowered machines was giving way to the age of relentless, single-minded efficiency. Airlines were were becoming obsessed with seat-mile costs. The 757, with its massive engines, was powerful, but it wasn't as fuel-efficient on short routes as its smaller cousin, the 737 Next Generation. At the same time, on longer routes, airlines were increasingly opting for small wide bodies like the Boeing 767, which offered more passenger comfort and cargo capacity. Sales for the 757 began to slow. Boeing looked at their order book and made a fateful decision. They concluded that the market space the 757 occupied, that awkward middle ground between the largest narrow body and the smallest wide body, was no longer relevant. They believed its roles could be covered from below by the newest, stretched versions of the 737 and from above by the upcoming hyper-efficient 787 Dreamliner. In 2004, after 1,050 had been built, the last Boeing 757 rolled off the production line in Renton, Washington. The factory was retooled. The book was closed. Boeing believed they had made a clean, logical business decision, but they hadn't just discontinued a product. They had unknowingly created a performance vacuum, a gap in the market that would grow larger and more problematic with each passing year. They had made a fatal miscalculation. Boeing thought they had closed a chapter. Instead, they had just created a ghost, a benchmark that their own future products would fail to meet. Here's where the story gets really strange. As the 2010s rolled on, airlines began retiring their older 757s. They replaced them with the aircraft Boeing and Airbus said were the future, the Boeing 737 MAX 9 and the Airbus A321neo. These new jets were marvels of efficiency, with quiet cabins and stunningly low fuel burn. They were perfect for 90% of the routes the 757 flew. But then airlines ran into the other 10%, the hard stuff. They tried to fly the new jets from hot and high airports and found they had to leave passengers behind. They tried to operate them from airports with short runways and found they were range restricted. They tried to launch new long-haul transatlantic routes and found the planes just didn't have the legs or the power, especially when flying west against strong winter headwinds. The 737 MAX simply couldn't match the 757's combination of range and performance. The Airbus A321neo came closer. It was a spectacular aircraft. Its newest variant, the A321XLR, or extra long range, finally gave a narrow body the 757's transatlantic reach. It could fly for up to 11 hours, connecting cities that had never before had direct service. But it still wasn't a 757. While it matched the range, it couldn't replicate the raw power and field performance. It couldn't rocket out of a short runway with a full load like its predecessor. It was an almost 757, a brilliant compromise, but a compromise nonetheless. The ghost of the 757 now defined fleet planning across the globe. Airlines were stuck. They were operating aging, less efficient jets because there was literally no new aircraft on the market that could do their job. The jet that shouldn't exist had become the jet they couldn't exist without. The industry knew it had a problem. Airlines were practically begging for a solution. So why couldn't the biggest aircraft manufacturer in the world just dust off the old blueprints and build it again? The truth is, building a modern equivalent of the 757 is ruinously difficult and expensive. For years, Boeing studied a potential successor, a clean sheet design they called the NMA, or New Midsize Airplane, unofficially dubbed the 797 by the industry. It was envisioned as a small, twin-aisle wide body with the economics of a narrow body, perfectly targeted to fill the gap the 757 had left behind. Airlines like United and Delta were desperate for it, but the numbers never added up. To achieve the required efficiency gains over the old 757, the NMA would have required a revolutionary carbon fiber fuselage, brand new engine technology, and an entirely new manufacturing system. The development cost was estimated to be north of $15 billion, and for all that investment, the potential market was seen as a niche, perhaps 2,000 to 4,000 aircraft over 20 years. It was a massive financial gamble. bubble. Then came the 737 MAX crisis, which consumed Boeing's financial and engineering resources, and the global pandemic, which shattered the aviation market. The NMA was officially shelved. The dream of a true 757 replacement was dead. The industry had to face a hard reality. The unique economics and engineering philosophy of the 1970s that created the 757 are gone forever. Modern certification requirements, development costs, and the relentless pressure for incremental efficiency gains make building such a specialized, overpowered aircraft nearly impossible to justify. So instead of replacing it, the industry pretends its substitutes are good enough, and in the meantime, the old warriors fly on. Airlines like Delta, United, and Icelandair continue to operate their aging 757 fleets, some jets now over 30 years old, because there is still, to this day, nothing else like them. The winners in this strange story are the passengers and routes that still depend on the 757's unique flexibility. Secondary airports across the globe, from Keflavik in Iceland to Ponta Delgada in the Azores, owe their transatlantic connections to this aging jet. It allows travelers to bypass major hubs, creating a more connected world in a way modern, hyper-efficient planes cannot. The losers are the airlines, forced into costly compromises. They must either run oversized wide bodies on low-demand routes, burning money on empty seats, or stretch underpowered narrow bodies to their absolute limit. And the biggest loser of all is Boeing. The company is haunted by the gap in its own product line, a constant reminder of a decision made 2 decades ago. Every new product discussion, every strategic meeting inevitably circles back to the problem of replacing the jet they themselves killed. The story of the Boeing 757 isn't just about nostalgia for an old airplane. It's a profound lesson about the blind spot of innovation. In the relentless pursuit of maximum efficiency, the aviation industry lost something just as valuable: versatility. It optimized its machines for the 90% of missions that are easy and predictable, and in doing so, it forgot how to build a tool for the difficult 10%. It's proof that progress is not always a straight line. Sometimes the most capable machine is the one you built 40 years ago. The jet that was supposed to be dead became the immortal benchmark that modern aviation, for all its technological brilliance, still cannot reach. Was the 757 a brilliant, unrepeatable accident of engineering? Or is its story a warning about the dangers of chasing efficiency above all else? In an industry facing the dual pressures of climate change and razor-thin margins, that question has never been more urgent. But one thing is certain: we will never see its like again. Check out another one of our videos here.